Now that we've seen rolling offsets in practical use, let's think for a minute about boxes and squares and triangles. And that's all we're dealing with. Triangles are ratios. The three angles of the triangle, when added together, will always equal 180 degrees. So we have, if this was 90 and that was 22.5, this would be 67.5. It would be a lot steeper angle. But say this is a 45, 45, 90 degree triangle. So 90, 45, 45. If this is 1 and this side is 1, then this would be 1.414. There's ratios, like I said. So if this was 1 from this corner to this corner, this side would be 0.707 and this side would be 0.707. And that's why if you know if you're using 45s coming in and going out, you can multiply one side times 1.414 and it will give you this side. Or if you have a piece of pipe for your travel and you say, well, I wonder how far up that would throw us. Well, if you've got a piece of pipe 1 foot long, then you know it would throw you up 0.707, assuming there was no takeouts. So to do the 45 degree rolling offset, a squared plus b squared equals c squared. Then we take and we get rid of the box here. And you have your hypotenuse. Just so happens this and this are the same length. So that's why you can turn around and go a squared plus b squared equals c squared, or you can take this times 1.414 will give you that, and then you can take that times 1.414 and it will give you this dimension, and that only works if you're doing a 45 degree rolling offset. Now I'll show you something. The difference between using 45s in a rolling offset and using 22.5s. Look at the difference between the two. 22.5s coming in and going out are going to throw you a lot further forward. Now these two start out breaking over 1, going up 1, and this is still 1.414. But because we're using 22.5 degree fittings, now we have 1 by 1 by 1.414, but you're coming in with a 22.5 and it's going to kick you a lot further before you go back out. So this would be 1.414, this would be 3.4136, and this would be 3.6949 if you do your math correctly. So if we wanted to measure it, now remember this is rounding, so if we can get our cursor in the right position here, we'll see we have a dimension of 1. And if we go down and we can get it to stick in the right spot, I can prove it to you. 1.414. And then if we go end to end, 3.41. And if we want to cross, 3.69, and that would be what you'd be looking at if you had a 22.5 degree rolling offset. So where you put the numbers makes a big difference in what order you do. And you can see from this representation how much of a big deal it is to do your job correctly and learn the math. Thank you.